These are notes for section 2.5 today. So we're moving right along. And in 2.5, we're going to take a different turn here. You've been working on the parabolas. And remember, we've got y equals ax squared plus bx plus c. And that's called a quadratic function. Just a little review here. Its graph makes a parabola. Recall that the parabola will open up if a is positive. The parabola will open down if a is negative. And in order to find that axis of symmetry that splits it into two equal pieces, we use the formula x is equal to the opposite of b over twice a. And that's what we've been working on up until today. So that's just a kind of a little review. So it's going to take a turn here for the next few sections because you're going to be doing what we call solving a quadratic equation. And we've got, actually there's 4 ways you can solve quadratic equations. And in this course we cover 3 of them. So the next few sections are going to be the same essential question, and it's going to be how do I solve a quadratic equation. And so a quadratic equation, the difference between it and a quadratic function is that instead of a y here, there'll be a number. So it might say 4 equals or 5 equals. A lot of times it says 0 equals. And there are 3 ways to solve them depending on what the equation looks like. So today we're going to do a very algebraic method, which is going to be to solve by using square roots. Now, we in this course tell you how to solve. So when you take the test, it'll say solve these by using square roots. But ideally, eventually, it'd be nice if you would know when to use what method. So we're going to put that in here. Even though it's going to say to solve by using square roots, we use this when b equals 0. So what it looks like is something like this. You end up with maybe 2x squared plus, let's say, what would I like it to be? 1 is equal to 9. And you'll notice this is called a quadratic equation because it's got that x squared in it. However, whenever you're doing algebra and you're trying to solve for x, you always do what's called the opposite or inverse operation. So when b is equal to 0, notice there's no x term in here. It's ax squared plus c. There's no x term in there. And when that is the case, they're kind of easy to solve because we can just attack it with pure algebra. Watch me do that on this one, and then we'll go back and do some easier ones. But if I'm trying to figure out who x is and trying to get it all by itself, so I'm going to go circle it right here. I want to isolate x. And I can do that with just straight algebra. All I need to do is get rid of the 1 by doing its inverse operation. Addition gets undone with subtraction, and I'd write 2x squared is equal to 8. And again, I'm still trying to figure out who x is. The thing being squared is the x, so we need to get everything away from that, which means I have to get rid of that 2 out front, and it's 2 times x squared. So I do its inverse operation, which is to divide. Those cancel. and I get x squared is equal to 4. So now I just need to figure out how do I undo a square. And the inverse operation is square rooting. And let's talk about why. Let's go off to the side here. If you put your favorite number 3 in your head and square it, you'll have a 9. And then if I tell you to square root that, the square root of 9 is 3. Notice how this root basically canceled out the squaring. Let's try it again. If you take 5 and square it, you get a 25. But when you take its root, you're right back to 5. It's like these two, the root and the square, just kill each other off, like addition and subtraction. They're called inverse operations. So if you take your favorite number x and you square it, and then you take its square root, you get x. So when we're trying to isolate x or solve for x, and can get it down to just x squared, all we need to do is take a square root. So really what you do with these is you do what we call isolate, which means to get it by itself, the x squared. Once you do that, you can just take a root. However, if you isolate x squared, I'm going to put a watch out, put a pair of eyeballs here. I should have used blue for a pair of eyeballs. But you do have to watch out for this. If you're isolating x squared, so those mean watch out, and you go get it by itself by subtracting. And you get a negative over here. Go point at that. This will be one of the questions I ask you when you come up with your notes is, well, what happens if you get a negative? And the answer to that is, when you take the square root of both sides, you can't root a negative. And the reason is because there's nothing times itself that would give you a negative 4. And you might say, well, negative 2. But if I do negative 2 times negative 2, a negative times a negative is a positive. You can't root a negative. So when you have a question like this where you end up trying to root a negative, you write no solution. Now let's talk about some common sense and why this should make sense. What you're being asked to do is find a number that when you square it and you add 5 to it, you get a 1. Well, you can see how that would be impossible because no matter what number you put in for x and square it, it'll always be positive. You might even put in negative 10. Well, a negative 10 times a negative 10 is a positive 100. So no matter what goes in for x, the minute you square it, it's going to poop out something positive. And then you're going to add 5 more to it. And there's no way you're going to end up down at 1. So we're going to watch out for no solution because off to the side here, we cannot root negatives. Put it in a circle and put the slash through it. All right, so when that happens, we write no solution. The other thing, you need to really know your perfect squares because if x squared is equal to 4, then you might say, well, the square root is this, and we get x is equal to 2, which is true, but we also have to put a little plus or minus on here because another set of eyeballs. So this is going to be easy, but we've got to watch out for some details. You'll also have to put this plus or minus on here because watch when you go check it. 2 times 2 is 4. But negative 2 times negative 2 is also 4. So we get 2 solutions most of the time. So we have to remember our plus or minuses. So now what we need to do is split this, and let's talk about numbers you should know the square root of. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81, and 10 times 10 is 100. Those are what we call the first 10 perfect squares. And I could go on and do that forever, but these are the ones I need you to recognize, and here's why. You need to be able to know what their roots are without a calculator. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. The square root of 36 is 6. Square root of 49 is 7, 8, 9, 10. So these all have perfect square roots. Now anything in between these, let's go sneak up in between 9 and 16. The square root of 10, nobody knows. It goes on forever. It never repeats. You could make it a decimal, but I'm not going to have you do that. Anything other than those in your list, you can just leave your answer as a root. So I'm going to write leave it. So we're going to go practice a few of these, and then you'll go grab a worksheet. So for some examples, I'm going to pick ones that are similar to the ones on your worksheet. We are going to pick, I'm grabbing the worksheet here, I'm just going to go change a couple. We're going to start off nice and easy, and we're going to say k squared is equal to 66. The next one we're going to do is a squared is equal to 9. Then I'm going to bump up the difficulty a little bit, and I'm going to do negative 5x squared is equal to negative 500. And then I'm going to go over here, and I'm going to do x squared is equal to, I'm going to make it 1649. And then I'm going to start adding and subtracting a little bit, and I'm going to say 10x squared plus 2 is equal to 50. No, I don't want it to be equal to that. I'm going to make it equal to 252. Well, that'll be interesting. And then lastly, I'm going to do, this is going to be number 28 on your worksheet, so you can go look at this one. I'm going to do this one, and then I will discuss one more when we're done. So these are the 6 we're going to do. My goal is to isolate the one that's being squared. X squared or k squared or p squared or whatever I'm working with. Well, on this one right here, it already is. So all I need to do is the inverse operation. And when I square that squared term, I just get k. Now, this is not in your list of perfect squares. So again, your perfect squares went 1 times 1, 2 times 2. 8 times 8 is 64, so it's really close, but this you get to just be done. If you want to go make it a decimal on your calculator just because you feel comfortable doing that, you certainly can. For number 2 here, again, it's already isolated. All I need to do is take the square root. And I would write, by the way, I should put a plus or minus here, and that's actually really important. So sorry about that. I need to put that on here. On this one, the square root of 9, now that's one I need to recognize. That is a 3, and I need to know that without a calculator. And it's actually going to be plus or minus 3, and let's discuss why again. 3 times 3 is equal to 9, so that works for A. Negative 3 times negative 3 is also equal to 9, so that works. So we got to remember our plus or minuses. On number 3, I need to isolate this x squared here, which means I need to get rid of the negative 5. And you might think, oh, I'm going to add 5. It's not x squared minus 5. It's negative 5 times, and the minute you say times, you need to undo that with division. These will cancel, and I want to see all this work on your worksheet. And you'll get x squared is equal to a negative divided by a negative is a positive 100. And then to pop off that squaring, I need to take the square root. And I should know the square root of 100. It's in that list of perfect squares. And I get a 10. But I need to remember the plus or minus. On the next one up here, again, I'm got to isolate x squared. 16 times it, so I need to divide by 16. And I get x squared is equal to 49 over 16. In order for me to get that, once we isolate these, remember we take the roots of them and it just pops that variable out, which is nice. So I would say this is x, or this is k, or this is p. Well, when I do this, I'm going to get what x is, but whatever I do to the left, I have to do to the right. Now, should I know what the square root of 49 over 16 is? And the answer is yes, because this is a perfect square, it's 7 times 7, and this is a perfect square, it's 4 times 4. Now, I want to pause for a second and circle this, and I want you to think about why I will send you back to your desk to fix that one. And that's another thing I'm going to ask you when you come up is when you're done, what's the last thing you have to remember to do? And the answer to that is put the plus or minus in front of it. All right, next one up. Again, I am trying to isolate x squared so I can take its root. So what I need to do is get that plus 2 out by subtracting 2. And I'll get 10 x squared is equal to 250. Next, in order to get x squared all by itself, the 10's got to go. That's 10 times x squared. So I divide by 10. I cancel, cancel, and I'll get x squared is equal to 25. Now that I've isolated x squared, I take the root. And I get x is equal to 5. And I can't forget that plus or minus on there because both of these, when I square them, give me a 25. So last but not least, this one. So let's go grab this and begin. To isolate that, I need to get this 3 out of here. It is a positive 3 right now. If I add 3 to it, I'll get up to 6. I think some kids think, oh, I add for this one, but you don't because you've got this subtraction here. So you need to subtract 3, and that'll get rid of it. And you get negative 4x squared is equal to negative 88. Now that's kind of weird, right? But let's keep going. In order to isolate this x squared, I divide by negative 4 and divide by negative 4. X squared is equal to 22. And in order for me to solve for that, I take a root and I take a root. Now, should I know the square root of 22? No, you shouldn't. 4 times 4 is 16. 5 times 5 is 25, but 22 isn't one of those perfect squares, so you are allowed to just leave it. If you desire to go make it a decimal just because it makes you feel better, I certainly wouldn't mark it wrong. So before you go grab the next worksheet, it's going to be yellow and it's going to say number 5 on it. I also want to have you beware of one like this. Let's make that plus 11. And let's make this, how about a 7? So watch this one. Last one up, I promise. These are kind of long notes, but it's kind of an involved section. It's got a lot of algebra. So I subtract 11, and I move along my merry way. I get negative 4. And then I follow my rule that to undo multiplication, I divide, and I get a negative 2. And then I remember that once x is isolated, I take its root. Right here, you're going to stop. You cannot root negatives. So what we do is we say there's no solution. And when you get your worksheet, I'm going to tell you that you should end up with that answer for only 2 questions. All the other ones have solutions, and not only that, they all have 2 solutions because of the plus and minus. All right, you're ready to move on to number 5. It's yellow. Good luck and have a good day, guys. Peace out.